Welcome to ADF TV. My name is Nimphius and I'm from the Oracle JDeveloper and ADF Product Management team. In this session we talk about application security, and it's a second recording out of 4 recordings that we have on this topic. In this session I want to talk about design principles, design patterns, and I want to start going into the details and talking about input validation. For design principles and design patterns, you might think, well, that's common sense. Why are you teaching common sense? Keep in mind that this training is for everybody, and we make no assumption about the skill level in terms of security knowledge that the viewer of these videos have. Also, there might be people that come from a different background than Java EE, so they are new to this topic, so we want to make sure they understand the full picture. In the first recording, I did talk about the Open Web Application Security Project and the top 10 of security threats that this group releases. Now we're kind of going closer to what the cure is, which is secure guidelines and patterns. So let me start with security principles. The 2 principles that I prefer talking about are secure coding and the security by design. Now, secured coding is more about secure defaults. Whenever you work within an application, there's some sort of parameters you would expect, or some sort of context parameters. And security is a context information, is an information that you get for an authenticated user, for the authorization or whatever. So some of your programming parts will rely on that. Think about one of the top 10s I talked about, which is the failure of restricting direct URL access. Now, if you make a wrong assumption about if a user is trying to access one of the pages within the flow of your application, and you don't have this protected because you make the wrong assumption, then obviously your default setting for this is wrong. Same for Java code. If you execute a query and you expect a bind variable, then if this bind variable is not passed by, then it should not query all of the records, and thus unveiling data that you want to keep secure. It should not query at all. So these are safe secures. The best analogy I can give you is an elevator. Imagine you're in an elevator and eventually there's a power outage. Now, how do you want this elevator to behave? You don't want it to go down, you want to pull the brakes, right? So how did the engineer know that you wanted to pull the brakes? Obviously, there's some sort of secure guidelines and secure thinking in the engineering of elevators. Now, the same for your application. So not everything that we can provide within this training is all technical. Something is just awareness. So we need to be aware of what security risks are. Security by design is another topic. Security by design means that you get your head around what really is a security threat for your application, and also what is the ecozone or the ecosphere that your application exists in. Now, I talked about different security threats in the previous session. Now, there are more than 10 security threats, and I think there are thousands or hundred thousands of security threats. Now, protecting against everything is very expensive and maybe useless as well. So you want to have for your application a clear idea of what is the protection that your application needs. And I tell you what, your application doesn't need all protection, it just needs enough protection. Enough protection against the risk that you can anticipate for the application. Now, do you have an online business? Then probably failover or availability of the whole application is very important to you. So flood, power outage, or earthquakes, that's a problem of yours, because if your business is not online, you're not making any money. If your application is an internet application and it's only used 5 days and only within business hours, you probably will have enough time to play in a backup or to reinstall the application just in case that the server fails. So you see that different security risks and different risks that you need to consider for your application, and then you spend whatever is required to spend to protect the application against this kind of failure. When I talk about the ecosphere that the application lives in, we talk about corporate constraints like the single sign-on system. Now, we have a lot of customers that authenticate application against the database schema because they did that in the past. Now, this in Java EE sounds like a niche problem or a niche use case. Typically, you will have some sort of identity management that your application has to live in. Now, in Oracle, if I built a program for Oracle and I want to deploy it for every Oracle employee to use, I will have to integrate with the Oracle single sign-on, which is the Oracle Access Manager, because that is a corporate standard and there are corporate policies I would have to follow. Same for you. The application itself, you want to define for your application policies or security requirements. Of course, yes, input validation, that's an easy one, that's a low-hanging fruit. But you might have some policies or requirements which is like a frequent re-authentication. If you have a very sensitive data, you want to make sure that the user frequently re-authenticates so that you have a session expiring earlier than in other applications. You want to make sure that the user is always authenticated, so you don't let him to any page in your application without being authenticated. Or you want to have message encryption. So this all needs to be written down somewhere, and this somewhere are security code guidelines. And you need to have these guidelines, because if you don't have the guidelines, now what do you want to test against? So you see, a lot of common sense I'm teaching here, but in reality definitely needed. The next topic I want to talk about is dependency. Now the dependency that security has with usability and performance. You can imagine that if you have a very extensive security system with a lot of policies checking and frequent authentication and whatever, you're tipping on somebody's toes. Either it's performance, because you have a lot of policy checking, or it's usability, because you ask users to remember very complex password policies, or you ask them to frequently renew passwords, or you ask them to re-authenticate, and so on and so on. So the triangle of this dependency is something that you have to consider. I'm not saying you should sacrifice security for performance. However, if your business is an online business, then performance is very important. So you might implement the security you need, but you will forget about over-securing your application. So you will focus on the areas that really need protection, and on other areas where nothing could be stolen, you might be more relaxed on that, so that performance is as good as you need it. And think about online stores, a millisecond really makes the dollar here. So this is important. Now, how do we know how we can implement this? Well, lucky us, like in building houses, there are patterns in software development as well, and there are security patterns. On the slide here, I only implemented some of the patterns. I'm not implementing all of the patterns. If you really wanted to read of many patterns, more than I listed here, here's the book. This is a book written by Sun employees before Sun turned to Oracle, and you see it's a quite big book. Now that's all about security patterns. Security patterns are no implementation details, but they give you guidelines. Now you find similar patterns online, so that is Google for security patterns, and you find some. The most popular, however, are defense in depth, which is the old saying of don't put all your eggs in one basket. So you try to use a layered approach for security, so that when the first line of defense falls, you still have another line of defense backing this up. In Oracle ADF, the lines of defense would be the view layer, the binding layer, and the business service. And if you call out to a remote service, like a web service, then that is another line of defense. And the database also is a line of defense, because if data protection is your concern, then that is a line of defense as well. What about the client, browser, JavaScript? Well, that's a convenient layer. It's not really security, because the easiest thing to hack is JavaScript. However, you have several layers of defense that you can use, and as I will show you in the third recording, in Oracle IDF you use that exactly. So the next is least privileged access. No, only because you're the corporate database administrator, it doesn't mean that the travel request application or the expense application that you run needs to run with your full power privileges. So go with the power that you need, or the privileges you need to run this application. And that could be that the application has its own privileges, so it connects to its own schema as a database user with least privileges, with only those privileges that are needed to run the application. No create table, just create instance or session and so on. Now the benefit here is if then your account gets hacked, so if someone authenticates to the application as you, no matter what they try, they will run with least privileges and not as the DBA of the whole thing. Single access point. Single access point is where you want to enforce users to go after authentication and ideally before authentication as well. Think about buildings. So every building you want to protect with a guard. If you have a building with 12 floors and you might have 4 buildings, then that makes 48 floors to protect, but you still need 4 guards. If the buildings only have 3 floors, you need a lot of buildings and therefore a lot of guards. So it's a lot more complicated and complex to protect a lot of entry points to your application than a single entry point. So one of the things that you can do in Oracle IDF here is to use bounded task flows. Bounded task flows, if they're using JSPX documents, have a property called URL invoke that you set to false, and then they're inaccessible from a browser. So that means you have one landing pad and the rest is automatically blocked down. But you see, I'm talking about bounded task flows. It's not a security feature. Of course, yes, and I will talk about this in the fourth recording, where I will give you a hint on thinking out of the box what you can use for security. Checkpoint is another pattern, and that is that you frequently, or actually that you look for hook points where you frequently check whenever data is updated. Take for instance ADF business components in the do DML. So before an entity updates, you can check if the user is authorized. Or you just have central points where you perform checkpoints. So no matter how the user on which we view the user accesses the entity, you will enforce your security in a central point. Roles. Now this is a common concept where instead of giving the privilege to individual users, you group users into roles, which is easier to administer. Imagine a company with 100,000 employees, and now you want to give them detailed privileges and you give them to every user. It's a huge set of permissions that you're dealing with, and that definitely will end up in misconfiguration, one of the other Oracle Open Web Application Security Project top 10 vulnerability issues. Yeah? So misconfiguration. So avoid misconfiguration with a role concept. In ADF security, as we will see in the next recording, we have 2 roles that we're dealing with. One is the user group or the enterprise user role, and the other one is the application role. So we have 2 abstraction, 2 roles, and that allows us to make an easier approach for administration for ADF security. Then we do have full view with errors. Now this is for qualified personnel like QA or like support. They need to see exceptions. So if there's anything going wrong in the application, then the best and honest view onto the problem is the stack trace. However, unfortunately the stack trace tells you a lot about the technology being used. If the error comes from a database, sometimes you can even tell what the database is. Now experienced hacker will make use of that information if you present this to them. So what you want to do is, for the user who is running the application, you show reasonable information about an error, but no stack traces. And the way to do this is to, for instance in Oracle IDF, work on the error handler. The error handler is a central piece in ADF, and I would talk about the error handler in a separate recording where we talk about error handling in general. You can override the default error handler in Oracle IDF, and there you can skip errors, or you can suppress errors, or you can change error messages. Now, if you add security checks in there, in the error handler, then you can say, okay, if the user is an authorized support engineer, I show the stack trace as part of the error message. And then we do have a limited view. Well, this is the definition or difference between managers, for instance, and employees. Managers see manager views which contain salary or sensitive information which you don't want to show to employees. Or a consultant, a sales consultant, can see more data on the same view than the customer can see. So you enforce this through permissions and authorization. And then we have the concept of sessions. So instead of passing tokens around that identify a user session that we maintain and set up, remember one of the top 10 was a failed session handling, we rely on a session managed by the container. We make sure that this session cannot be stolen or just redirected. So that's what we have to say about security. Guidelines and patterns. Remember, there are documents, there are books that give you a lot more information about guidelines. And these are just guidelines. Choose those that meet the needs that you have for your application and see how you can implement them. And the next 2 recordings, including this one by the way, will give you more details on how to do this in Oracle IDF. So next I want to talk about input validation. Now, input validation, I think, is a common problem area in applications because SQL injection, cross-site scripting, or LDAP injection, this all happens on the input level. Now, users are not bad in general. However, some might exploit input or free text input to see what they can do within the application, if they can get information that they're not supposed to see. Now, first of all, you have the direct user input. One way, for instance, to kind of reduce the surface, the attack surface on the application would be to not have free input text fields, or at least as many. Just guide users with radio groups, with checkboxes, with select lists, with dependent select list, list of values. So don't let them type anything in. So that, at least from the input level, will protect you from accidental malformed information or just wrong copy and paste that could cause troubles on the data side. Of course, the hacker wouldn't mind. They would just look on the transport level and would try to change the data in transit. However, you're reducing the attack surface. You at least don't make it easy. But we have more input to data than just user input. Think about other access channels. You have a mobile? Mobile could be an entry point to your application, right? At least to the data. SOA, what about SOA? A service could be called from another service and feed into your data stream. PL/SQL, SQL+, or you have Oracle Forms. Well, these are all entry levels to data. Now, if you have business data, then for sure you have more than one client talking to the business data. So that means that from a perspective of security, it's not enough to just protect Oracle IDF or Java EE applications. You need to have consistent security implemented on all access paths. And this is the important key here. So just a heads up on thinking about other clients accessing it. Request parameters can also be used, or cookies or tokens. Yeah? So applications can do a lot with data passed by a parameter, and if these parameters, for instance, are not secured, if they're not encoded, then you might run into a problem. Now, how can we protect you, or actually how can you protect your application? Well, what you can do is you can use validators. Well, JavaServer Faces provides you a list of validators, starting from format validation, pattern validation. ADF Faces comes with a regular expression validator that allows you to check for string patterns. You have dependent list of values that you can use just to guide and control users. You can have the the value change list now on an UI component to run a check, and this then is only on the view. From here it goes to the ADF binding layer, and from there to the business service. If you work with ADF business components, go to the entity object, and there you have business rules, and these validation rules are almost the same as on the JSF layer. You could have length validation, numeric validation, compare validation, regular expression validation as well. And you see, I do have an option on JSF, and I do have an option on ADF-BC, and I do have an option on the binding layer. So I could build multi-layer defense strategy for failed input and just by performing input validation. Another thing to keep in mind for protection in JavaServer Faces is the ability to use a converter. Normally you use a converter to convert a string to an object, because everything in the browser is a string, even a date field. So you use converters to turn a string into a date object. You could use converters, however, as well to encode data. So even on a string field, I could use a converter to just convert the input string into an encoded string, which would protect me from cross-site scripting. So JavaServer Faces and ADF both provide hook points for you to implement security. So, as you would guess, there's always a gotcha with it. And the gotcha is that what does it make sense to protect the front door if there are no locks on the windows, or even the windows are wide open? And let me tell you a story about a customer, and I'm not giving you the name because I want to protect the innocent here. So this customer did a great job in protecting Java EE applications, well, in particular ADF. So ADF was completely locked down, and they did a great job integrating with identity management, learning the lessons about ADF security, which we talk in the next session, and still, in the database they found SQL injection attacks, well, traces of these. And they recognized that actually they got this through an access through PL/SQL. So someone else with a different client was not protecting it because they don't have a centralized security setup. Now, if it's all about data security, the closest to the data you can get is the database. So the database will have to have the last call on security. So if you have too many areas or too many points, non-central points where you apply security, risk is that you actually fail protecting all of the entrance layers. Think about my example of 4 big high buildings with 12 floors and then several buildings with 3 floors. So it's quite easy to forget to protect one of the entry points here. There is a list on this slide about follow-up material that you want to read. There is a Security for Everyone, which is an article in Oracle Magazine which comes with a sample. Get this and get the sample and you have an introduction to ADF security, though we'll talk about this in the next session, so don't hurry, just get it. We have security documentation, the Fusion Developer Guide, and we do have a reference to this book, so there are more books than that. And I wouldn't say that this is the best book on the market because I don't have read all of the books, so I can't tell. But however, just for those interested, because I showed that book, you may want to have a look and maybe you enjoy it and it helps you to protect your applications.